We are finally starting on our calculus power rule, positive integer powers. And notice that's what we have here. 7 is a positive integer. Integers are regular numbers, 1, 2, 3, 4, 5, or 0. And then integers could also be negatives, -1, -2, -3. So that's what we got, and we're just sticking to the positives now. Okay, so we're asked to do the derivative of this function right here. So I used to be confused by this when I was a student. So let's break this down right here. dy over dx. This is really an easier to look at if we move the y out in front, which is totally okay in math. So what this is saying is the derivative, D-E-R-I-V-I-T-I-V-E, the derivative with respect, got to give it respect, to x. All right, and notice there's the x right there. That's the one that we respect. So what that means is anything that's not in x is considered a constant or considered just a number. X is the only one that we want to focus on here and give it the respect of the derivative. So that would be our basic input idea. So basically x is our input, y is our output or our function name, and then we're applying the derivative idea. And remember, derivative basically means the slope at any point. So all we do here is we got y equals x to the 7th. We take that x to the 7th, and my strategy, the way I think about it, is the exponent moves out front, and then you subtract 1 from the exponent. So this is first. First, we move the number out front, and then we subtract 1 from the exponent. So that would be the second step. All right. So the 7 moves out front. And then I would say 7 minus 1, and that would be 7x to the 6th. And what that does is it gives you the slope at any point we plug in here. So then we would just say dy dx is equal to this. And it's also nice to note and start getting used to it. That prime means the same thing. This is a better form because it tells you what letter or variable we are respecting, but usually most often we are respecting x. And so that would be our derivative symbol here, the prime. Okay, let's see how we did. 7x to the 6th. Great work. Got it. All right. Same thing right here. All right. Notice it's just built a little bit different, but good thing I kind of set you up with it. So this is d dx of x cubed. So do you remember what I said? This is telling us to do the derivative with respect to what letter? With respect to x. So of this function. So it's kind of this instead of the y. So we would just go ahead and apply our power rule to it. All right. So let's see if I can't generalize what the power rule is. So it'd be like x to the a. If y equals x to the a, then y prime would be a x to the a minus 1. All right. So whatever that number is, it moves out front, and then you subtract 1 from it. That's all there is to it. So I would go ahead and take my x cubed. I would move the 3 out front and then subtract 1 from it. So 3x to the 3 minus 1, 3x squared. And then that's our d dx, the derivative with respect to x of x cubed. All right. And then a lot of times you can do this in your head. So I don't really mind that as much, but just sort of recognize that just writing things out a little bit and reminding yourself, and that's a prime right there. That's a prime. Writing things out and just reminding yourself of the form just really helps as things get more complicated. 3x to the 2. Got it. Next one, Same style, so all of these should be pretty straightforward using that same philosophy.